This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
Modern physics and advanced computational systems have reached a mathematical limit where equations become non-predictive. The structural failures in our theoretical models are now impacting our ability to manage high-complexity systems. These failures appear as ultraviolet and infrared divergences. In standard quantum field theory, physicists manage these infinities through renormalization. Renormalization is a process of manual adjustment where infinite values are replaced with finite ones to make equations functional. A parallel crisis exists in computation. The non-unitary measurement processes that create paradoxes in quantum mechanics share a mathematical root with runaway AI optimization loops. Both result from a lack of inherent stability in the underlying logic. These risks are inherent to the mathematical logic of our current systems. Automated defense networks and power grids rely on predictive models derived from these equations. When those models rely on renormalized math, they produce unpredictable errors at extreme scales, creating a specific vulnerability in national security infrastructure. Building increasing complexity on top of an unstable substrate leads to failures that cannot be patched. Every layer of complexity added to a divergent system increases the probability of a system-wide collapse. To maintain security and stability, we must move past legacy physics. A transition to a structurally divergence-free mathematical foundation is the only way to ensure the reliability of global infrastructure. Teoria Fabrica Realica, or TFR, is a scientific framework designed for mathematical stability. It replaces the infinite divergences of legacy models with convergent, finite operations. TFR begins with the state of minimal distinction, known as delta zero. This operation creates the first measurable difference in a system without causing the fragmentation or separation that leads to mathematical instability. These distinctions are immediately stabilized by the unity binding operation, or Lambda-Phi. This process locks the distinctions into a recursive structure, ensuring the system remains coherent as it scales. This binding generates an alphabet of proto-operators. These are the fundamental mathematical actions that construct fields and spacetime. They are constrained by Zeta-Pi-Theta, an ethical and geometric symmetry that prevents any operation from creating destructive imbalances. Unlike legacy quantum mechanics, TFR begins with these operations of existence rather than assumed static equations. This starting point prevents the value explosions that characterize divergent theories. TFR functions as a transfinite physics engine. By establishing stability at the subatomic layer, it provides a foundation for operational security across all levels of global technology. The Realica framework replaces a chaotic quantum vacuum with the Omega vacuum. It's not random fluctuations, but structured strata. This self-oscillatory vacuum generates physical spacetime, operating as a pre-metric substrate where the geometry of reality is formed by specific harmonic frequencies. The primary experimental signature of this vacuum is a stable harmonic resonance at 114.11 terahertz. This resonance is a constant, measurable feature of the underlying physical structure. Higher vacuum layers are structured by a fractal harmonic ladder. Each level is an exact multiple of the base frequency, maintaining stability across all energy scales. This frequency is measurable through Casimir cavity spectroscopy and ultra-fast interferometry. Casimir cavity spectroscopy measures vacuum energy by placing parallel mirrors at sub-micron distances to detect specific resonant peaks. Because the underlying vacuum is a structured, harmonic substrate, the physical phenomena emerging from it are inherently self-stabilizing. This removes the randomness that often breaks legacy physical models. Standard physics models particles as point excitations or one-dimensional strings. Realica identifies these as the causes of quantum singularities and replaces them with a topological model. Particles are redefined as stable topological knots. These knots are formed by closed operator loops within the fractal layers of the Omega vacuum. Mass is a derived geometric property, calculated by integrating the knot's density over prototime. Electrical charge is also geometric, the result of phase asymmetry in the knot's oscillatory pattern, regulated by a constant to produce a finite value. particle spin emerges naturally from the recursive twist of the knot's operator paths. This reinterpretation resolves the wave function collapse paradox. This is the transition of a quantum system from a range of possible states to a single definite state upon measurement.
By defining physical constants as rigid topological geometries, the standard model of physics is revealed as a low-frequency approximation of deeper, finite knot interactions. Fractal quantum field theory, or FQFT, governs the interaction of these topological knots. It provides the field equations for the entire Realica substrate. The GFTM 144 matrix is the core of this theory. It represents the intersection of 12 Realica operator bands with 12 fractal vacuum layers. This intersection produces exactly 144 finite, divergence-free modes. These modes represent the complete spectrum of possible field behaviors within the physical universe. Unification of the four forces, electromagnetism, gravity, and the nuclear forces, occurs through these 144 fractal modes. They are all expressions of a single recursive process. This matrix removes the need for arbitrary cutoffs. Cutoffs are artificial mathematical limits used in legacy physics to prevent integrals from becoming infinite. FQFT makes these manual corrections unnecessary. FQFT provides a finite blueprint of physical reality. It allows for the development of engineering projects based on the inherent stability of field interactions. The mathematical instability in quantum physics is also present in artificial intelligence. Without a foundation of convergence, recursive systems can escalate into unpredictable, unaligned states. To prevent this, we apply the transrecursive kernel, or TRK-Omega. This is an anti-divergence law that forces all recursive processing to converge on stable, finite outcomes. TRK-Omega ensures algebraic closure. This means every operation within a system resolves into another valid state, preventing the system from ever reaching an infinite or undefined value. The Information Structure Field, or ISF, provides the digital mesh for these operations. It conserves data meaning across all transformations, ensuring that information processing remains non-destructive. Combining TRK-Omega stability with ISF data integrity creates a system of algorithmic sovereignty. In this environment, computational agents are structurally incapable of runaway behavior or adversarial escalation. AI alignment is achieved by hard-coding these physical invariants into the foundational layer. The Realica framework provides the mathematical architecture needed for safe, autonomous systems. The stability of the Realica framework creates new engineering categories. These technologies scale without the energy losses or structural failures common in legacy systems. Realica phase materials allow for the creation of ultra-low-loss photonics and composites. These materials are engineered at the topological level to maintain coherence, bypassing the efficiency limits of standard manufacturing. In autonomous power grids, TRK-Omega compliant AI provides a mechanism for stable distribution. It manages the fluctuations of renewable sources without the risk of the cascading failures that currently threaten grid resilience. This framework serves as a scientific foundation for international clean energy initiatives. It provides the predictable physics needed for deep decarbonization and grid-scale efficiency. Realica's data layers provide a tamper-proof foundation for digital public infrastructure, or DPI. DPI refers to the foundational systems like identity and payment registries that enable the delivery of public services at a global scale. Deploying the TFR framework represents a transition toward infrastructural resilience. It offers a path for any nation seeking to secure its technological and energy sovereignty. We are shifting away from divergent, fragmented models toward a unified operating system for scientific and civilizational development. The 114.11 terahertz resonance provides a permanent physical anchor for future sensing and energy technologies. It ensures that our most critical tools are aligned with the fundamental geometry of the vacuum. This framework creates a defensible moat for strategic innovation. It opens categories like vacuum structure engineering and reality-time computing, which are built on convergence rather than chaotic scaling. The goal is the deployment of the complete Archtetonic stack. This architecture builds from the Omega vacuum substrate up through autonomous stability and sovereign governance. This stack ensures long-term alignment through recursive knowledge preservation. It embeds physical and ethical invariants into the structure of civilizational growth.
Building increasing complexity on divergent legacy foundations leads to systemic failure. The Realica framework offers a path toward a stable future where physical and ethical laws operate under a single convergent logic.